Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we will be taking a quick look at asteroids. This is how I remind you of the Geminid meteor shower. I have covered meteor showers in a previous video, so you can take a look back at my previous videos about meteor showers. I was mostly dealing with the Leonids in that meteor shower, but here we are on the night of the 13th and 14th, and the Geminids just over here, the Geminid meteor shower. I mentioned in my previous video about meteors that they are normally caused by comets and the trail of dust that comets leave behind as they orbit around the sun. This meteor shower is created by what we call a minor planet or an asteroid, Phaethon. And this asteroid is, well, an asteroid. Some asteroids also produce clouds of dust and gas. Some of them even emit streams of particles, like a volcano. Usually it is cryovolcanism. So normally it is a frozen object that is squirting out of these asteroids due to differences in pressure and temperature. And Phaethon leaves behind a trail of dust. A lot of asteroids are a little bit dusty, a little bit fuzzy. Asteroids have enough gravity to pull objects in towards them, but not all of them are very tightly bound. Some asteroids have a lot of loose material on their surface, and of course this can get lost and be distributed through space. And when that little bit of dust falls into our atmosphere, it creates a shooting star or a meteor. If we get a lot of them, that's our meteor shower. So the Geminid meteor shower peaking on the night of the 13th and 14th. So this is an advanced warning. It is coming up. That is a meteor shower generated by asteroids. And we do have an asteroid in the sky over the next few evenings, Vesta. Vesta is a particularly famous asteroid because it's so visible. Vesta is a very bright asteroid, so it is, under ideal conditions, visible to the naked eye, or so I've been told. I've never seen Vesta just over here up above Betelgeuse in the east early in the evening. I've never seen Vesta with my naked eye, but apparently in dark skies under perfect conditions, one could. Apparently the same is true for Uranus, and I don't really believe that. But with Vesta, maybe. Vesta is a lot smaller, but it is also a lot closer to us. So let's have a slightly closer look. We're looking into the body of the Milky Way here, very close to Orion. So we are seeing a lot of these nebulous shapes. That very bright object there is Vesta. Vesta is a very reflective asteroid. It's its own special type of asteroid, a Vestoid, because it contains pyroxene and other reflective minerals. Now, my orbital elements are out of date, so Vesta might not be in exactly this position. I might need to update my software. But this is Vesta. It's nice and round. It's certainly big enough to become round, and it is orbiting the sun, but it's not after clearing out its orbit. Vesta is still called an asteroid. It's still an asteroid by the current definitions, whereas other round objects that are big enough to be round, some of them have been reclassified as dwarf planets. So dwarf planets became famous, of course, with Pluto. But I think that the sad story of Pluto being reclassified, it's maybe not outweighed, but at least balanced by the fact that Ceres, the largest asteroid, has been reclassified as a dwarf planet. Last time I checked, Ceres was not visible at night, so we are going to have to look for this dwarf planet during the day. Last time I checked, it was very close to the sun. You can see that I checked pretty recently. There it is. We'll go back to morning time. This wouldn't be a good idea. Actually trying to look at Ceres in this position with a telescope. It's far too close to the sun. But if we get rid of our atmosphere here, that'll stop any light bleeding through, and we should be able to take a closer look at the largest asteroid, the queen of the asteroid belt. Ceres was the goddess of cereal in Roman mythology. That's where we get cereal from, the name at least. So this is Ceres, nice and round, and it's got these lovely cracks and things on its surface. So Ceres is believed to have some frozen material on its surface forming these cracks, making it reasonably reflective, but not quite as reflective as Vesta. So there's Ceres, number 1, the biggest asteroid, queen of the asteroid belt, and also a dwarf planet. So there it is. It says dwarf planet up there in the corner. Ceres is, well, both. It's a dwarf planet in the asteroid belt and the biggest of the asteroids. These definitions are a little bit nebulous themselves along the edges. Ceres is number 1, Vesta is number 4, so of course there are 2 in between, Juno and Pallas. And luckily they have numbers 2 and 3. So let's see if I can get Pallas to come up with a 2, or maybe a 2 with brackets. There we go. There's Pallas. Now, you may have noticed that with Phaeton it was 3,200, so there are quite a lot of asteroids out there. Pallas, similarly nice and round. There we go. Still a nice round shape. Not quite as big as Vesta, but it is out there. It is reasonably large, big enough to be round. And when it comes to objects in space, their size does have a big effect on their shape. Smaller objects in space have the opportunity to be lumpy. They don't have enough mass to generate enough gravity to force themselves into a round shape. I really do hate to burst people's bubbles, but we're not going to be getting a cuboidal or toroidal planet anytime soon. We won't be getting planets shaped like cubes, simply because planets, once they reach once an object in space reaches a certain mass, its gravity will force it into this spherical shape. And being a sphere is part of the definition of being a planet or a dwarf planet. And Juno, Pallas, Vesta, still classified as asteroids. There is a chance that that could change. Who knows? We might end up with more dwarf planets in our solar system. Wouldn't that be nice? Juno, Ceres, and Pallas and Vesta, they're all in the asteroid belt. So they're reasonably close to us. They're just outside Mars. They're closer to us than Jupiter. And that makes them a little bit easier to see. Some asteroids travel far outside the asteroid belt. Some of them are associated with distant planets like Jupiter. We're going to use a feature of stellarium, hopefully, to allow us to take a look down on the solar system from above. This point is known as the Solar System Observer. There we go. So this brings us to really an imaginary point in space where we're up above the poles of the sun. So we can see the planets as they orbit around the sun. If I put the sun into the middle here, and if we move time forward a bit, there we go. We can see the planets as they orbit around the sun. And we can see how Mercury, if I can get this to go backwards, there we go. We can see how Mercury is moving way, way faster than the other planets. And then Venus, and then Earth, and then Mars, and then Jupiter, and then Saturn. The further out from the sun, the longer your orbit takes. But I'm not interested in those big planets. I'm interested in something with a very interesting orbit. And there we go. 3,753 Kini, or Kunya. Kunya, if you want to pronounce it in modern Irish, it would have been Krytnia in older Irish, or Krini or Krinia in English, if you'd rather pronounce it that way. This is an asteroid. And it's an asteroid that almost orbits the Earth. Not quite, but almost. Kini does something very interesting. It orbits the sun and the Earth. It's influenced by both of our gravities. So if I can get my orbits to show up here, I should be able to demonstrate how it moves through the sky. So here we go. Show orbits only for the object selected. And there's Kini. Doesn't seem to be coming up. Comes up for Mars and the other planets, of course, but not for something so small. Hopefully I will be able to demonstrate the way it orbits the sun regardless. So let's go through this. This is going to take a while. So there's Kini. It's orbiting the sun pretty much in the same place as the Earth. Now, if you're sharing your orbit with other bodies, usually you don't classify as a planet. One of the reasons Pluto was declassified from a planet to a dwarf planet is because it was sharing its orbit with other objects. But the Earth, even though it's sharing its object with Kini, its gravity is influencing everything that it's sharing its orbit with. The Earth's gravity is actually slowing down Kini here a little bit as it passes the orbit of Venus, passes inside Venus's orbit, and then zips around the sun again. Now, that sort of slingshot effect, a gravitational slingshot, as it passes around the sun. So because of the way Kini interacts with the gravity of these other planets, like Venus and Mars, it can be slowed down in its orbit and approach quite close to Earth. but it's not orbiting us. It's being affected by our gravity, but it's still orbiting the sun technically independently. So you can see that the Earth is almost catching up with Kini here, and then it zips away again, almost like we're chasing it. And then Kini gets pretty close to catching up with the Earth on the other side before the gravity of other planets slow it down and give the Earth a chance to catch back up again. So if I was able to draw out the lines of this orbit, it would be a pretty complex horseshoe shape. And not every object in space is orbiting the sun in a simple ellipse. Some smaller things like Kini and the asteroids around Jupiter, the Trojans and the Greeks, they're moving around in a much more complicated orbit because of all of the different factors involved. So there's Kini. The Kini, or the Crythne, were a group of people who lived in Ireland, up north in Antrim Down and Derry. So that is a semi-satellite of the Earth. It's not technically orbiting us directly, but it is going around the same orbit as we are, and its position in space is influenced by our gravity and the gravity of other bodies. So let's get ourselves back down to Earth here. There we go. And that will bring us around to the end. So I hope you get a chance to see Vesta. Vesta is observable. The other asteroids that I mentioned, Pallas, Juno, Ceres, they're certainly observable with a telescope. Kini, well, only observable on certain times of the year, those times of the year when it's close to us before it gets slingshotted back around to the other side of the sun. So it might be difficult to see, but I hope you get the chance and at least you got to see it here. If you enjoyed this video, make sure to subscribe to the YouTube channel and like the video so that I and YouTube know that you enjoyed it. And if you'd like to read a little bit about this topic, you can check out queevinscontent.ie, where I write a little bit about all of these videos. So thank you for joining me, and I hope you will again next time.